The hidden cost of the AI boom. Water is needed for development, production, and consumption that we are overusing and polluting an unsubstitutable resources and system. 8 safe and just boundaries for 5 domains: climate, biosphere, water, nutrition, and aerosols have been identified beyond which there is significant harm to humans and nature, and the risk of crossing tipping points increase. Humans have already crossed the safe and just Earth system boundaries for water. To date, 7 of the 8 boundaries have been crossed, and although the aerosol boundary has not been crossed at the global level, it has been crossed at city level in many parts of the world. For water, the safe and just boundary specifies that surface water flows should not fluctuate more than 20% relative to the natural flow on a monthly basis, while groundwater withdrawal should not be more than the recharge rate. Both of these boundaries have been crossed. These thresholds have been crossed even though the minimum needs of the water process to access water and sanitation service have not been met. Addressing this need will put even greater pressures on already strained water system. AI potentials. Technological optimists argue that artificial intelligence (AI) holds the potential to solve the world's water problems. Supporters of AI argue that it can help achieve both the environmental and social sustainable development goals (SDGs). For example, by designing systems to address shortage of teachers and doctors, increase crop jobs, and manage our energy needs. In the past decade, research into this area has soared exponentially, with potential applications including increasing water efficiency and monitoring in agriculture, water security, and enhanced wastewater treatment. AI-powered biocement can more accurately detect toxic chemicals in drinking water than current quality monitoring practice. The potential for AI to change the water use in agriculture is evident through the building of smart machines, robots, and sensors that optimize farming systems. For example, smart irrigation automates irrigation through the collection and analysis of data to optimize water use by improving efficiency and detecting leakage. As international development scholars who study the relationship between water, the environment, and global inequality, we are curious about whether AI can actually make a difference or whether it exacerbates existing challenges. Although there is peer-reviewed literature on the use of AI for managing water and the SDGs, there are no peer-reviewed papers on the direct and indirect implications of AI water use. AI and water use. Initial research shows that AI has a significant water footprint. It uses water both for cooling the stuff that power its computations and for producing the energy it consumes. As AI becomes more integrated into our societies, its water footprint will inevitably grow. The growth of ChatGPT and the similar AI models has been hailed as the new Google. But why a single Google search requires half a million liters of water in energy? ChatGPT consumes 500 milliliters of water for every 5 to 50 prompts. AI use and pollutes water through relative hardware production. Producing the AI hardware involves resource-intensive mining for rare materials such as silicon, germanium, gallium, boron, and phosphorus. Extracting these minerals has a significant impact on the environment and contribute to water pollution. Semiconductors and microchips require large volumes of water in the manufacturing stage. Other hardware, such as for various sensors, also have an associated water footprint. Data centers provide the physical infrastructure for training and running AI, and their energy consumption could double by 2026. Technology firms using water to run and cool these data centers potentially require water withdrawals of 4.2 to 6.6 billion cubic meters by 2027. By comparison, Google's data center used over 21 billion liters of potable water in 2022, an increase of 20% on its 2021 use. Training AI at the computing level of a human brain for 1 year can cost 1,026 liters of water. Each year, the computing power need to train AI increased tenfold, requiring more resources. Water use of big tech companies' data centers is underestimate. For example, the water consumption at Microsoft's data center was 4 times the intentional plans. Demand for water for cooling will only increase because of the risk of range temperature due to climate change. Conflict needed. The technology sector water demand is so high that communities are protesting against it as it threatens their livelihood. Google's data center in drought for the Dells War is sparking concern as its use quality of the city's water. Taiwan, responsible for 90% of the world's advanced semiconductor chip production, has resorted to crowd-seeding, water desalination, interbasin water transfer, and hazing irrigation for 180 hectares to address its water need. 180,000 hectares. Locating data centers. As water becomes increasingly expensive and scarce in relation to demand, companies are now strategically placing the data center in the developing world. Even in dry sub-Saharan Africa, data center investments are increasing. Google's planned data center in Uruguay, which recently suffered its worst drought in 74 years, could require 7.6 million liters per day, sparking widespread protest. What emerged is a familiar picture of geographic inequality, as developing countries find themselves caught in a dilemma between the economic benefits offered by international investment and the strain placed on local water resources availability. We believe there is sufficient evidence for concern that the rapid uptake of AI risk is exacerbating the water crisis rather than help addressing them. As that, there are no systematic studies on the AI industry and its water consumption. Technology companies have been tepid about the water footprint of their new products. The broader question is, will the social and environmental contribution of AI be overshadowed by its huge water footprint?